Welcome to today's class, and it is the continuation of class number 22, Kirchhoff's law and Wheatstone bridge. So Kirchhoff's law in the last class in 22 I have already mentioned, and today I will apply this law in solving out the complex circuit, and in Wheatstone bridge principle I will show how does it work. Am I right? So let us start the class with the figure. See question number 1, and you minutely follow. In this question you are asked find the current in the whole circuit. The circuit is given in this way. The problem you face is that there is no direction of current. Am I right? And there is no current I1, I2, nothing is given. So you have to make yourself the arrangement. So first of all, let us arrange. You see, this circuit I have drawn here, the same, exactly the same as above. Now the fact is that the direction of current, say here 15 volt and it is 10 volt. So current moves from higher voltage to lower voltage. So let us assume the current moves, this direction is I1. Am I right? So the current is moving in this direction, and this part is plus and this is minus. This is plus and minus. This is plus and minus. It is known to you all. Now let us, this current is coming in this direction, in this direction. Am I right? So again there is another source of battery, and from this let us assume the current number 2 is coming in this direction. We will not be concerned about the direction. If direction is wrong, the value of the current will be negative. We will make correction regarding the direction we assumed. So next one is this. Here again the current. How does current moves? So we'll assume the direction. Yeah, in this one, this is I3. So this is the first step of the direction of current I1, I2 and I3. This is not given in the circuit. And number 2, you have to specify the loop. So you have to give it A, B, C, D as you like. So the junction, this is very prominent junction. This is a junction. Am I right? So let us start from this A. This is B. This is C. And this is D, E, F. Am I right? So we have labeled it by A, B, C, D. Am I right? Now the third point is here that you have to assume the loop. So there is two loop. One is A, B, C, D, A, and another is A, D, E, F, A. And last one is you remove this one A, B, C, D, E, I, E, F. So let us start solving the problem. Let's see junction rule. Now let us start solving the problem. So here we will apply junction rule. You see outside circuit, this side and this side. In this side there is two current I1 and I2. These two current will be the same as the sum of the outside circuit, or these are in the same direction. If you assume minus and minus, this will be plus. Am I right? Opposite direction. So I3 is equal to I1 plus I2. This is first rule. I3 is equal to I1 plus I2. This is your first assumption. Let us assume it 1. You minutely follow one solution. You can solve out each and every one applying this concept. Now loop rule. Let us assume first loop A, B, C, D, A. A, B, C, D, A. means current has started from this point and again it is coming to this while traveling and coming again to A, means this is your first loop. So for first loop we'll start the passing current in this direction, am I right? So the in the cell the current entering minus to plus, so we will assume minus to plus means plus. It starts from minus to plus, answer is plus, so you assume 15 is plus. So when we will come to this, here it is voltage drop, voltage equal to IR, current into resistance, current into resistance. This current into resistance means twice I, am I right? And this is voltage drop, so this is minus. Or when it moves, the current moves towards the resistance in this direction, it is minus, and if it is moves out opposite to this, it is plus. Now come to this one, again the current enters here. Now earlier it was minus to plus, now it is plus to minus. When it is minus to plus, we assume this plus. When it crosses the second cell, plus to minus, answer is minus. So here this one equal to minus 10. Again it enters in this direction, it is opposite to this direction, so I2 into V means IR, here voltage drop, it will be voltage gain. It is reverse of this one. If it is minus in this direction, now it is in opposite direction, current is moving in this one, this current is in this direction, so this will be plus V is equal to IR. Here I is equal to I2, R is equal to 4, and this is equal to 0 according to Kirchhoff's loops rule. So this is equation number 2. Now come to this loop. Here it is A, D, E, F, again A. So loop A, B, A, D, E, F, A. Now for this loop, it starts from A and current is passing along the resistance. So first you are getting voltage. So now the direction is this, current is entering in this direction, am I right? So coming in this direction, so it is moving towards this, means voltage drop. So voltage drop is equal to VIR, V is equal to IR, so I is equal to minus 4I2, am I right? So it is coming in this way, and here it is passing through minus to plus. So minus to plus in cell, if it is minus to plus, answer is minus 25, and again this is entering toward this one. So here I and R equal to voltage, and voltage drop is current into resistance. Let me repeat here at this point, when it is minus to plus, the V is plus, and plus to minus, V is plus and minus, so current is passing from minus to plus, that's why 25 is equal to plus, am I right? So you are getting 2, 3. So the now trick is that our unknown quantity of the current is 2. One is I1 and I2. If you can find out I and I2, automatically I3 will come. So two unknown variable is I1 and I2. We need two equations to solve out two variables. It is known to you all. But besides, if you want to check the third loop, the last loop is to start from A. A, B, C, D, E, F. Again A, B, C, D, E, F, A. If you assume this loop, so it starts from A, minus to plus, voltage is plus, it is 15, am I right? Here I is passing across the resistance twice I, so it is minus, voltage drop, means twice I1. It is entering in this term plus 2 minus, answer is minus. It is 10. It is coming in this direction, again entering here, minus 2 plus, then B is this. Again this I is along the direction of 5 ohm to reach at V. So it is voltage drop. It is along the direction voltage drop. So this is equal to 5 into I3. Then when it comes to that point where it started, answer is 0 according to Loops law. Now you see one thing, if you add up these two, you will get this and these two cancel out, and you are getting 15 plus 25 minus twice I minus 10 minus 5 by 3. That is, the last loop which we have considered is nothing but the sum total of these two. So this is nothing new, redundant, because it does not give additional information. We doesn't require this equation, already these equations are there. So we will efface out this equation. Am I right? We have checked it. Now, so far our knowledge concerned, we are concerned with I1 and I2. So out of these two, we will find I1 and I2. So first we will try to find out I1 and then I2. We will place these two. This is simple algebraic calculation. So from this 2, from 2 we get 4I2 I2. Again from 3, let us find out I3 is equal to now 5 minus 4 by 5 on simplification, simple simplification of equation 3, we get 5 minus 4 by 5 I2, and already we have got the value of I2, 5 minus 4 by 5, and I2 is equal to this, I by 2 minus 5 by 4. Simple calculation is 5 minus 2 by 5 I plus 1, 6 minus 2 by 5. So this is the value of I3. This is I3 and this is I2. Simple, we have got I2 and I3. We'll just place this in 1. So from 1 we get, what is I3? It is 6 minus 2 by 5 I is equal to I1 we don't know, plus I2 we have calculated, I by 2 minus 5 by 4. So now just we missed out I1, so I have placed here I1. So I have I1, I1, I1. So here you get 6 by 5 by 4 is equal to 2 by 5 I1 I by I1 by 2 plus I1. So in this way I have that I1 is equal to this much. We have not preferred here decimal because we will get the exact answer. So if we put the value I1, just you put this value from here. Simple calculation, you put the value of I1 here, you will get I2. So from A we get I2 is equal to I1 by 2 means 145. So we have calculated I2 is equal to 25 by 38. So simply using equation 1, I1 plus I2, we can get I3. So I3 is equal to I1. What is I1? I1 is equal to 145 38 and I2 is equal to, you can deduce it, you will get the answer. So this is all about the trick and the way how to solve the Kirchhoff's law. And in Kirchhoff's law we have seen we need two things. One is junction rule, other is loop rule, and we will just combine and we will do algebraic problem to find out the solution. So in Kirchhoff's law, we have already calculated with the help of the diagram given the current in each resistance. We have calculated there is some algebraic solution, you can know it, but the main fundamental trick is that you need to find out the junction, and from this you write the junction rule, and then you utilize the loops rule, and with the help of this two you combine and solve out, you will find I1, I2 and I3 or whatever current is required to be calculated. Now as per our scheme, we need to find out Wheatstone bridge and Wheatstone bridge principle, and we have drawn the Wheatstone bridge in this way, and we have just arranged four resistances in such a way, and inside the middle there is a galvanometer to detect the current. Am I right? So the main principle is that thus 2 and A and C of the four resistance connected in this way are connected to the source with some specific EMF. Am I right? And when current is made to pass through this one, say current I, it enters, it goes in this direction, is go in this direction. Am I right? And the resistance of 1, 2, 3 are chosen in such a way that these resistance are arranged in the values of resistance are chosen in such a way that this resistance, if it is unknown, will adjust this resistance to get that current through this is 0. Current to this galvanometer is 0. This is called null point. So our arrangement should be in such a way. Am I right? So we have assumed this is current I1, a resistance R2, R1, and I1, say I2, R2, I3, I4. I4 Rx. So current I1, I2. Here why we have assumed these two currents same, because if you assume to get the balance that no current through this diagonal point through this G, that means the same current I1 is passing through this path. That's why when this is I1, we assume this is also I1, and when this current here it is passed through, if it is I1, I2, I3, I4, am I right? So we have assumed I1, I2. In I2 it is I1 because no current is this as per the condition. So this I1 is going to this one, hence it is I1. So we have assumed I1, I2, I3. In place of I2, it is I1. So this is I3. Am I right? So the current I3 is passing, and it will not again pass through this one, as there should not be any current. The resistance should be adjusted in such a way so that I3 current is passing through this direction. Am I right? So since it is I3, again this is I3, because no current is passing through this, same current is going in this direction. So direction of the current, and this resistance is assumed as unknown resistance Rx. So what we see here, that the potential difference between point B and C is 0. If we consider that there should not be any current between these two, that is through G, so that is potential difference between B and D, point B and D should be 0. That is sum of potential through this, between these 2 points is 0. Let us now apply the condition. We know this is I1, this is I1, R1, R2, I3, and this is Rx. We don't know the value of this resistance, and we will adjust the value of this resistance so that ratio of these resistances will be same. So to get the same resistance value, the Rx unknown will be calculated. So if the potential across these two will be 0, is 0, then there should not be any current. So if we assume the Loops law through A B D A, Kirchhoff's law, A B C D A. So what's happened? The current is passing along the resistance. We earlier mentioned, if it passes along the resistance, it is minus voltage drop. And if you assume minus, if you assume plus, then the potential should be minus. Both the case it is correct. If you assume potential drop passing through this direction minus, then the potential difference will be plus. And if you assume this minus, and if you assume this minus, then potential difference plus. So if you do in other way, it is also correct. So A B C D A, current is passing in this direction. So I into R1. So coming in this direction, again it is going in this direction, it is opposite. So this is I2 R3, and plus there is some resistances, and there is no question of this. We will not assume this one, the voltage across this one, because here there is 0. We have assumed 0. This is equal to 0. Or we may write I1 R1 minus I2 R3. Both the cases the matter is same. So from this we get I1 R1 is equal to I2 R2. So this is 1. So now apply the Loops law to this point. So B C D B. Here assume I1 R2 minus, then this is reverse of this direction, this is plus, and again this is 0. We will not consider this one. Or you can write I1 R2 minus I3 Rx. Both the case your assumption is correct. So from this you get I1 R1 is equal to I3 Rx. So dividing 1 and 2, 1 divided by 2, we get I1 R1 Here we made mistakes. I1 R1 is this and I3 R3. We wrote it I2 R3. Am I right? So this is I1 R1, I3 R3. So I1 R1 divided by I2 R2, and this is I3 R3 divided by I3 Rx. So from this we get, sorry, R1 by R2 is equal to R3 by Rx, that is R1 Rx is equal to R2 R3. So what we get, that the ratio of R1 R2 must be equal to R3 Rx. If it is unknown, we will adjust this resistance in such a way that putting this value, the ratio of I3 R3 and I3 Rx means R3 by Rx must be equal to R1 by R2. That gives reading of unknown resistance Rx is the final answer. So from the relation we get R1 Rx R3 R2. Am I right? So there is the multiplication in crossway. The resistance are multiplied in crossway. Am I right? Means the product of the resistance this and that must be equal to this and that. So the value which gives the product of this and that will be equal to the product of R1 and Rx. So unknown Rx will be adjusted in such a way that value when put upon this one, R1 Rx value will be equal to R3 and R2. So that has got diagonal relationships of multiplication value. So if you take a simple example, let us see how does it works. We can find out the unknown resistance. Say this is the question, and this is the source, outward source from which the current flows in this direction in the Wheatstone bridge, where in the null condition the three resistance are 20, 30 and 400, and you were asked to find out X. So no need to do anything, no details of I1, I2, R3, you should not put all this, just to write the cross multiplication of these two must be equal to these two, that is X is equal to 20, 30 into 400. You are getting this, and this is 20, this is equal to very simple calculation I have done to apply this principle to find out the unknown resistance. So thanks a lot for watching the video, and please don't forget to subscribe the class to get updated video.